Want to know who we are? Let's start here. We do this, that, and we make all of these. We're here to connect and power just about everything around you. We help you save energy. We're not trying to save the world, but we are making the most of our energy and resources and making access to energy and digital basic human rights. Life is on.
Hello, everyone, and welcome to today's Industrial Control Systems Roundtable. I'm Christina Urquhart, editor of Manufacturing Automation Magazine and its companion website, automationmag.com, and I'll be your moderator today. First, I'd like to thank our sponsor, Schneider Electric Canada, for their participation today and help in making this roundtable possible. With that, I'd like to introduce you to our panelists in today's roundtable. So first, we have Christian Perrier, president of PCI Industrial Automation. Christian has worked in the automation and technology space for more than 20 years. He founded PCI in 2001 and says he loves sharing his knowledge and helping the future generation to get interested in the world of industrial automation. John Krajewski is a senior director of product management, monitoring, and control at Aviva. John has 25 plus years of experience in industrial automation and control systems, and for the past 10 years has served in multiple product management roles for Aviva, HMI, and supervisory control products. Sanjay Singh is the Vice President, Industrial Automation at Schneider Electric Canada and has spent over 19 years in the energy and automation solutions industry. He has vast experience in designing electrical control systems and automated solutions, as well as hands-on experience in programming PLCs, VFDs, SCADA systems, and more. And last but not least, we have Vic Riccardi, president and founder of RTS Consulting Automation since 1992. Vic helps companies integrate industrial systems and manufacturing execution solutions to achieve operational excellence through production data analysis and actionable intelligence. We are happy to have you all of you here, and thank you for joining us today. A quick definition as we get started. When we talk about industrial control systems, or ICS, in this panel today, we are talking about the devices, instrumentation, software, and the networks that are used to operate industrial processes, particularly when it comes to manufacturing. So with that, let's dive into our first topic on crisis management. So it has been quite a year for manufacturers. What are some of the weak spots in existing or legacy control systems that have become more pronounced during the pandemic? John, I'm going to turn to you first on this one.
Thank you very much, Christina. And first, I'd like to start by thanking our hosts for inviting me. It's been an honor for me to be asked to be speaking on this panel together. When it comes to industrial control systems and aspects of the pandemic that have made their issues more pronounced, if you will, we're seeing that, one of the most significant things that's happened as part of this is that, people have been separated. People have either been removed from the places of a point of work that they've been able to be at in the past, or needed to be physically separated from each other. And there's been a lot of strict restrictions inside of control networks, the specific points where they would have those points of access, whether it's an HMI or a SCADA position or another one there. But very often those things are very much restricted to be behind those firewalls for security reasons that are very solid. But if suddenly you can't get the people to those points of work, how do you facilitate those remote operations with separated people?
Vic, I'm going to turn to you next. Do you have anything you want to add?
Yeah, I would add, to John's points, I'd say, users of existing and legacy control systems really lack or have limited remote visibility and control to production operations, as certainly being one of the key weak spots, I believe. As well, hardware and software, or just general service support's been difficult. To get support on industrial control systems during the pandemic, with legacy systems presenting really an extended challenge, if you will, because many professionals are working from home, have travel restrictions, and there's that hesitation, to travel outside of their social bubble. So they may not want to go to site to try to do a deep dive to resolve some control system issues.
Christian, what are you seeing during the pandemic?
Well, actually, as John and Vic said, the pandemic makes it very difficult for on-site servicing. So if we're not able to reach their control systems remotely through VPNs, well, it puts a lot of pressure on maintaining and improving those systems. One other thing we found is, well, we all know with the pandemic, some parts became less and less available. So for the legacy parts, they are even less available. So that puts a lot of pressure. So that's what we found. Those were the weak spot that this pandemic got us to find.
Sanjit, how about you? What weak spots have you noticed?
Yeah, I mean, I think I would echo what everyone else said, and I'd add to that is I think the readiness for many of customers and plants today in terms of connected devices. I think we all talk about digital transformation, and I think some customers and some plants have been fast to adopt, and others have not. So I think one of the biggest weak spots we've seen is the lack of connected devices or remote connected devices within plants where I think we all have the intention to want to connect remotely and have data accessibility and keep machinery going. But I think as many plants look back at the assets, they weren't connected ready or did not have connected results. So to me, that was a big weak spot. And part of that was having actually aged equipment inside of the plants.
So, I mean, maybe you could follow up with that on an application example of a control system that maybe performed well during the pandemic that somebody had already installed and allowed one of your clients to respond in an agile way.
So I think in general, Christina, I think automation or automated processes was a godsend for many manufacturing facilities and customers. I think we all know that during the initial stages of the pandemic or the initial lockdown, many facilities were burdened. We're not having the labor force to keep machinery going. And I think this is where we saw that automation played a big part in allowing a lot of customers to keep machinery going at a reduced labor force, because there was a lot of automated processes. So I think that was key. And I think from an applications perspective, if I look back specifically at PLCs, HMIs, and SCADA, I think these automated devices allowed manufacturers to keep machinery going, and it also allowed a greater level of flexibility. So typically to the manufacturers that pivoted their machines, to help our great nation in terms of converting production lines to become mass manufacturing machines, I think that level of flexibility by having automation in place allowed that level of fast pivoting. So I think from an application perspective, I think automation is definitely something where people now see the benefit if they haven't seen it before, because we realize how quick we can use it to pivot and to deal with crisis.
I imagine the rest of you have seen that as well, that sort of automation has become a lot more important to clients, especially towards the last half of the year, as people are looking to 2021.
Yeah, and Christina, I would add to that really the ease of in newer control systems, the ease of remote SCADA and HMI visibility really has enabled the control professionals to support manufacturing systems throughout this difficult period. Total access to the operations from anywhere at any time, I think is paramount to supporting the operation. For example, today, most of the parameters from a production system can be viewed on a cell phone, and it doesn't matter where you are, you have that visibility, and you can control what they can and cannot see and do from a simple cell phone. So from that aspect, I think technology has served manufacturers well in this pandemic.
Yeah, I would back up what Vic says there, because I mentioned what was one of our biggest challenges with being remote operations. It wasn't because technology wasn't there to support it, or they say necessity is the mother of invention. The capability has been there, but a lot of the times the necessity wasn't there. Well, I have local staff. I don't need to do a lot of this remote capabilities. For a lot of our customers, when it came time that now it was necessity, achieving that wasn't a huge hurdle, right? It was just a matter of deciding that was something you needed to do.
I mean, how then for a company that maybe didn't have these systems in place, how can remote controlled software or monitoring be used to tap into an ICS? I mean, on a sort of a brass tacks level, John.
You know, we're seeing this in a variety of forms, right? And so whether it's remote operations or if it's facilitating overall organizational capability. And one of the things that we see in an emerging space is what I refer to as unified operations. By pushing the data up into the organization, what types of decisions can be made that will facilitate optimizations and other types of capabilities, facilitate other level business decisions. Sometimes I refer to this as IT and OT convergence, and that term sometimes can confuse people because a lot of times when people say IT and OT convergence, they talk about organizational structures, who reports to who. But when you start taking the information that sits in IT with the information that sits in OT and combine them together, which rarely happens behind those control networks, so you kind of have to move it remote and get it outside and get into those areas. The types of decisions that you're making, the efficiencies we're seeing, you know, major manufacturers getting millions of dollars of improvements in terms of their bottom line by being able to coordinate as an organization as opposed to operating in independent silos.
What control strategies should companies then consider if they have a geographically distributed supply chain? Maybe Christian, you can kick this one off. I know you're working closely with manufacturers in your systems integration work.
Yeah, it's a good thing. It's a good question. I'd like to say that this is where MES comes into play. MES stands for Manufacturing Execution Systems. Of course, it will vary from one industry to another, but mainly you have to leave the real-time control locally, but bring information up to a centralized location on site or in the cloud, I guess. But all this in order to have the big picture at your fingertips, and this in real time. So all this to be able to take efficient decisions according to your ERPs, and then push back those decisions in order to, or push back those decisions or orders back to the local plant. Actually, this is really the MES role, which is actually bridging the gap between the ERPs and the SCADA or ICS.
Okay. And I mean, how did your clients fare in the first few months of the year? If they didn't have those things in place, I mean, what kind of challenges did they have, especially when it came to the bottlenecking of supply chains?
Well, actually, it creates more delays, I would say. We have customers that use this MES. So what we see is actually the good side of it, and of course, what they've seen recently is just putting faces and putting more and more energy in those systems to make sure that they can have this information at their fingertips. So it really, yeah. If you don't, you're doomed if you don't have it, and if you do, you're just gonna put more and more money into it because you really feel the benefits of this, especially in those times.
Yeah, and you know, I can add to that, Christina, because you know, I think one of the things that I'm seeing right now from a supply chain perspective is the greater need for networked control systems, you know, both inside the supply chain and the supply chain outside of the key core suppliers. So it's almost the suppliers. And I think that level of network and connectivity from an industrial control system perspective is essential. You know, as we see, you know, the consumer market change, and we see that the demands of consumers becoming greater, we see that there's a greater need for traceability throughout the supply chain, where you don't just track and trace the finished product, you now need to trace the supply chain, the supplier, almost to the point where you have the component level right up until the produce level. So I think from that perspective, control systems are really helping to connect those dots, connect, you know, the supplier to the raw materials, almost a farm to fork type of mentality using control system.
And I mean, is the most common way that they're doing that through like RFID tagging, or how are companies able to track their products as they move through the supply chain?
You know, I think there's various methods and various forms. You know, I think, you know, some of our software platforms and working very closely with Aviva, we've seen that we have this traceability. Some of it is RFID, some of it is, you know, it's a general barcode scanning, but there's different processes. And, you know, I think it comes down to the various suppliers, the different manufacturers, and what you're trying to trace and how you're trying to trace it.
And if I may add, there's all sorts of ways to track or trace items. Yeah, we're used to RFIDs, barcode, and stuff like that, but we've seen the development on the very highly detailed pictures of a box or a product, which actually stands for an electronic signature. And this really allows, without any, well, of course, you got to have the material, the equipment on site to take those pictures, but actually it's the box in itself that is the RFID, if you may. So there is a lot of technology to choose from to do your traceability. But on top of everything, this is where nice softwares that are put into place to link those players from the different part of the process that makes it stick together.
Vic, I think you had mentioned, I think it was that you had mentioned that there's an ease of use to the software platforms now. I mean, why is that especially important now, would you say?
Yeah, absolutely. So we find that, these days with more and more senior or experienced operations people kind of going through the retirement cycle, if you will, the new generation that's coming up into the position just don't have that 20, 30, 35 years of experience. So a lot of our time in delivering front-end solutions or dashboarding of applications are focused on, one, initial wireframing of what the dashboard would typically look like. And then this wireframe kind of circulates at the client to the various people who are going to be using it. And in many cases, they always, scale it down and simplify it and just come up with, bare bones functionality, if you will. They would rather have perhaps two dashboards instead of have one that's cluttered. And so the ease of use goes up. It's much quicker to respond to something. When you get a notification on a dashboard, it's very clear, it's not cluttered. Much to my surprise, and I've been in the business for quite some time, in the old days, we used to create these beautiful colored dashboards. The colors would change, and if there was fluid in the pipe, it would go green or blue, and it would just be wonderful. And but that has changed. That has been proven, that is not the way. You really want a somewhat static, boring dashboard, very simplistic in nature, and it should only get complicated, or it should only get colorful when you want to specifically draw somebody's attention to a specific area where there's a problem and they need to take action. So, over the years, I've seen dashboards really kind of go from something that you would see in a cartoon to something that's very mundane and static until they really have to, kind of bring forward the information. So yeah, ease of use, just kind of directs the focus to the right area, and it caters to a wider range of individuals. You don't have to be a semi-subject matter expert on that process or that production equipment, to make a difference.
So bringing that information forward is a really key part of Industry 4.0, making that that connection between what's happening on the floor and the operator in the control room. So Vic, I know you're consulting on digital transformation initiatives and moving to Industry 4.0, moving companies into the smart factory. How would you say that modern control systems facilitate the digitalization of production lines and smart factory, and bringing it back to the pandemic, how does that really help in times of crisis?
Yeah, good question, Christina. Digital transformation is a multi-step process, but we really have to start with the business goal and the expected outcome to identify the high priority digital transformation initiatives that bring maximum value. Once this is established, a gap analysis is performed to look at, what are the top priorities, that we should be looking at. Where's the value? By starting with a business goal, we ensure that the project will be a success. Either primarily measured by improved quality or productivity, or ultimately improved financial performance, which in many cases is really, the key thing, is really what matters. And modern control systems are, very fast, provide high fidelity data as a result of their speed, of their lightning fast scan times. Many also have the ability to capture and store locally gigabytes of production data, as well as direct communication protocols for SQL and FTP and OPC UA and MQTT and many, many more. And this enables the control systems to store data to databases, either on-prem or on cloud for analysis. One of digital transformation's value points really comes from improving the business by deciphering the data, and I mean lots and lots of data, into production process improvements. One must also look at eliminating manually entered paperwork and Excel spreadsheets from the shop floor and automatically capturing this production process data directly from the equipment. And modern industrial control systems, of course, enable this data extraction with their high number of equipment connections, connections to IIoT devices, cobots, autonomous mobile robots, etc. So today's control system easily connects to external databases and cloud storage. And this data can, reside in local data ponds or private public clouds. And it's this data that really brings tremendous value by applying things like digital twins and machine learning or AI algorithms to provide various levels of analytics, from descriptive to prognostic. And this is the smart factory. And this is what I think, we strive for, many of our clients strive for, to get to, this level where, the factory has a certain level of intelligence and data that can be analyzed to really squeeze the final tweaks out of optimizing, the whole plant. And in a time of crises, operations and the business really need easy and detailed access to operational visibility across the organization to be able to make the best decisions. When the traditional support people at your side are all remote, one has to rely on the support information of the control system to make optimal decisions. That's kind of in a snapshot, my thoughts around it.
Yeah, I mean, that's a great overview of all the components. I mean, John, do you have anything that you want to add to what Vic's already outlined about the role of the smart factory?
I think Vic had a very fine point there when he started by saying you have to start with your business objectives. What are you trying to accomplish? Because when you look at modern industrial technologies, not all of them actually start with a control system, right? So, for example, if I'm looking to optimize a process, we may be doing things I hear them called shadow sensing. What's that? Well, instead of having to plug everything into a PLC, which may have a very high price point because I have to run conduit, I have to have remote I/O, I have to buy these transmitters. When you look at things like the industrial Internet of Things and the capabilities that brings to play, well, I can now read information at maybe less than an order of magnitude of cost than it would if I had to pipe that whole thing into my control system to give me more data to make better decisions. Just a moment ago, we were talking about the need for ease of use because we have more people from more organizations that need to be able to leverage that data. So not every aspect of it is for control. Some aspect may be for optimization. So putting the right tool in the right hands of the right people. Sometimes you have to push this data to the cloud, but how many people are willing to connect their PLCs to cloud systems? But that segregation of data and these modern technologies that bring that capability together allow us to solve the problems of today without having to worry about introducing concerns around security. So there's a lot of capabilities that are existing in the marketplace today, where today used to be everything on the production floor focused around connections to those control systems. Now we're seeing a diverse array of systems that are facilitating a diverse set of initiatives across an organization.
Thank you for that. Sanjith, how about you? Do you have anything you want to add on to smart factory discussion?
Yeah, I mean, if I look at smart factories, I think the phrase smart factories is in an evolution, itself today as we see, modernization and industrial control systems becoming faster, more efficient. So I think smart factories in an evolution. So when we look at smart factories, we can't just look at it from a production line perspective anymore. We've got to look up of the production line, right up to the supply chain. You've got to look past the production line all the way to logistics to your customer. And I think in doing that, you start looking at it more of an ecosystem. So we move from smart factories to smart plants and smart manufacturing. And I think when we do that, one of the key components in order for us to achieve the smart technology, the smart factory, the smart manufacturing, is by having smart devices. And it's by using industrial control systems and devices that are modern and equipped to give you that level of flexibility. So for me, I think there's so many things when you look at a smart factory, but I think it's bigger than just the production line. I think we've got to look at it as an entire ecosystem. And if we look at the concept again from farm to fork, and if we consider anything inside of that, that to me is the ecosystem that we need to look at and consider in terms of being the smart factory initiative.
Yeah, a little bit more of a holistic approach. Maybe we're getting tied up in jargon a little bit in terms of smart factory itself, but smart operations maybe. Christian, how about you? Do you have anything you want to add?
Well, I guess everything has been said, but on a different point of view, well, actually on an integrator's point of view, what I like with new modern industrial control system is the ease of use. Can it be on a point of view of the integrator or the end users? So, well, there is a quite brilliant person that I saw an interview a couple of days ago, which is Steve Jobs. Actually, he said we need to make the customer experience the best thing on the market. So instead of asking the engineers what can we do with what you have invented, they said we need to have this final result, and then we'll go see the engineers and then, okay, build this according to our user experience requirement. So we do it the other way around. So of course, at the early days of automation, which of course way before me, we were doing what we could. But today with the softwares, with the powerful CPU, the memory, the whole everything we have, we can make some very good user experience in terms of programming from scratch, and also the end user. So I'm sure John and with his team, they do tremendous, nice end user experience with their new software. So that's a pretty interesting progression that we saw on the industrial automation side.
Okay, well, I think that kind of wraps up our crisis management segment. We're going to move on to performance and profitability of industrial control systems. So, Sanjith, let's start off with you for this one. What are some of the things that signal a manufacturer's PLCs, SCADA, HMA, any other control devices are ready for an upgrade?
That's an interesting question. Very broad question, but very interesting. I think there's many factors to consider, but I think I would categorize it into three little buckets. I think the first thing is when you look at upgrades and when is the right time to upgrade your PLCs or automation equipment, it comes down to what is the customer or the manufacturing facility's appetite to stay abreast with technology. I think one of the things we see in the industrial sector today is that you have a lot of aged plants, and some of that is manufacturers today may not have the appetite, or maybe not even the funding to upgrade or to change equipment. So I think that's the first part, is the appetite to stay abreast of technology and to have the upgrades done. I think the second thing to look at or to factor in is the age of the equipment. As control systems age, there's a risk of failure and fatigue at the component level, which results in downtime. So obviously that's a key criteria to take into place when you consider when is the right time to upgrade. And I think the last one is regulation. As more stringent manufacturing principles get put in place, we see a greater regulation towards safety and safe manufacturing processes. And I think manufacturers have to look at their automation lines and their production lines and have a look at the level of equipment and the level of safety inside the equipment. And again, depending on where they are versus what the regulation stipulates, it might be a good time to upgrade. So I think it's a few things that come into play all at the same time. And I think as manufacturers start looking at their plant and they factor these three things, I think a lot of the time these decisions get made for themselves automatically. But then again, comes down to the cost and then the appetite. But I think there's so much of solutions in the market today that fit the various budgets, if you so to say. But I think overall, if you factor in those three key components, I think it'd be a very, very good broad criteria of how to assess your plant.
Mm-hmm. Does anybody else want to jump in on that one before I move on?
I totally agree. There's kind of two aspects to this, and one is how much longer can I really leverage the existing infrastructure that I have? Can I still get parts? Can I, still support it in case I have issues? That's on one front. But I think the thought leaders are driving and drive more to the aspect of what do I need to accomplish moving forward, and is that control system, going to get me there? So those two aspects, I think, really drive a big component of some of the legacy infrastructure and what people want their control system to do moving forward.
Yeah, I mean, as Sanjit was saying, there are a lot of options now that you can tack on onto what you already have. I mean, obviously, it's not always the most ideal solution, but there are things that you can do to sort of take that next step and get a bit more connected. Christian, as a systems integrator, what's the biggest challenge that you see that tends to hold manufacturers back from making a control systems upgrade?
Good question, Christina. Actually, there is a lot of reasons holding manufacturers to embrace the new technology. Specifically in terms of upgrading their ICS, mainly what we face when it comes to modernization is our customer misunderstanding the risk they all face. Once those risks are acknowledged, then they'll find that they all boil down to production loss. And when management understands that, then they will quickly move on to modernization. One other thing is that we often see old school veterans that have become experts at repairing electronic boards, VFDs and such. And today, not only that these repairs are getting more complex, but they require all new sets of tools. And also, those veterans are retiring. So thus, it's contributing a lot in raising the risk of longer downtime. So that's what we feel.
Vic, how about you? What do you think is the biggest challenge holding manufacturers back from upgrading?
Yeah, so I think it's, to a big degree, I don't see a lot of senior people in senior positions with the correct mindset, in that they may not truly understand today's technology and how it can deliver to achieve the business goal. There's fear of moving data outside of their environment, and as much as you try to convince them that it's safe, it's secure, it takes a monumental effort to try to hack into that data. They still have the hesitancy. Nope, not my data. It's not going anywhere other than these four walls. And even when you explain to them, well, your data right now is residing in a data center that's halfway around the continent, they still have this unease of looking at the technology that's available today that's going to meet and exceed your business expectations. So that I find, a bit of a stumbling block, if you will.
Sanjit, do you want to weigh in on this question?
Yeah, I think I'll echo what Christian and Vic said as well. I think those are the perfect buckets to put that into. I will say one of the things that I've seen a lot is the knowledge and expertise on modern or new control systems. I think as human beings we are creatures of habit, and there's an old maintenance or plant saying, if it's not broken, don't fix it. And sometimes you have that mentality where the plant's been working and it's 8 years old or 10 years old, in some cases 20 years old. You don't want to touch it, right? Because on the day you do, it's going to break. And I think some of that mentality holds us back from trying new technology and moving into what's new. So I think for me that's what really stands out is that appetite to try new technology and to venture away from what we know today to what's new and what's modern and what's going to be the next evolution in industrial controls.
Okay. John, do you want to add anything on that one?
The one aspect that I think I'd add to this discussion is the notion that availability of systems, while being being critical in almost every industrial process, we're seeing more and more of these industrial systems that are moving into areas of infrastructure. And likely what I hear from a lot of my customers is I may have 1 or 2 hours a year that I can be down, that they can be scheduled to be down. And that downtime to them is such a problem. So what they face here is that the risk of, well, if I try to take this down to an upgrade, do I have to put 2 systems up simultaneously? And very often you see these guys trying to change out the engines on the airplane while the thing's still in flight. It's a very difficult balancing act. And that balancing act is one that no one takes the risk lightly. So that risk to their, to the availability of their systems, and a lot of times they may not just be manufacturing, but they may be, handling water production or handling water cleaning or generating power, and so many different aspects of this industry that we see these things used at. And we're seeing more and more segregation of systems to be able to handle that. So the monolithic nature of a lot of the old school systems actually led to this. Well, to touch anything, I had to bring everything down. So, we're starting to see things become more segregated. Well, this aspect of this manual is that so that I can keep control going if I want to update this optimization system, let's say on the side here. So we're finding more ways that we can elegantly leverage things like the cloud, where nobody would typically put control systems in the cloud, but you can bring that to bear because the cloud also brings certain areas of things like, upgrading on the fly to other aspects of that. That's second nature to things you do in the cloud. Does anybody have to go and upgrade their Netflix? No one has to do that. It's just handled for you. And those types of notions, that we'll start seeing them permeate into industrial space eventually to address these areas of downtime.
Yeah, I mean, this is connected to what you were just saying, John. We've got an audience question here asking about if once a PLC system is connected to the internet, is continued update a problem? And I think that's what you're talking about here. With once you're connected, you're kind of good to go nowadays.
You know what? Good to go might be a difficult statement to sanction, because I know typically if I go into a control arena and ask one of my customers to connect their control systems to the internet, the pitchforks and the torches come out and they start chasing you away, because this is not something that there's a lot of risk, right? Connecting it to the internet, there's other risks that they have. So yes, maybe I manage the downtime by having that ability to streamline and upgrade, but I also introduced the risk of downtime of other people being able to get into that system. So that's where I was suggesting that you'll start to see more functional segregation. The systems that are less at risk of being able to impact that downtime, those are the ones that they'll tend to connect first. Those ones that are often responsible for safety, mission critical control, those kinds of things, they'll be connected to the internet probably when you're prying from someone's cold dead fingers, right?
Mm-hmm.
and John, to one of your points, we have very good example in water production, right? Drinking water production, where we've spent quite a bit of time in taking, programmable logic controllers and SCADA infrastructure that was, as you said, monolithic in the past, and going in to those systems like surgeons to shut down various aspects of the process so that they could be transferred to, secondary PLCs and SCADA systems, just to take this big monolithic beast of a control system and to start to surgically carve it up so that it can be, distributed throughout the system, so that if you needed to bring primary water operations down, you could do that without affecting the secondary part of the plant. So yeah, your point is bang on, John.
We've got an audience member here who said that they started connecting old equipment through AEDAM modules to collect information from lines in real time, and then are working with the data for continuous improvements. And they're wondering how you have dealt with old equipment and the need of connectivity, especially now in 2020 with everything that's been happening with COVID. And if you have any struggles or lessons that you could share.
What I see here is, in many of these cases where people are talking about legacy equipment, you have to realize, what is the reasonable life of that? And people are looking better to measure it. I have some customers who have equipment that's been in operation for 100 years, no reason to touch it, and others that have equipment that's been in use for 5, and that one probably needs to move quickly. So often age isn't to quite tell. It's to understand how well is it meeting the business objective. So if you installed this piece of equipment, it's going to give you value. Is it still maintaining that value? What's the likelihood? So we're starting to see, the advent of technologies like artificial intelligence and machine learning to be able to identify what is the reasonable life expectancy of that asset, so that you can understand: do I need to replace it? Do I need to maintain it? Can I just continue to let it do its job? But ultimately, capital expenditure that can be preserved is gold, right? No reason to buy it again or have to rebuild that. So extending the reasonable life of assets has become a huge thread.
And Christina, to your point, or to the to the audience's question, we've not that long ago worked on injection molding machines that were built in the 1960s, operated just fine, no issues with them, but obviously we couldn't get any metrics. We couldn't get any KPIs out of these, relics. In essence, we advised to put a small, low-cost PLC saddled to the machine. In this case, they did not want to move the data to the cloud, but we moved it to an on-prem database. And so with this, I think it was a $600 PLC that was strapped onto the, the machine, the injection molding machine from the 60s, and we were able to, again, strategically pick points that needed to be monitored so that we had visibility to things like cycle time and idle time and mold changeover time and all of these things that enabled this in essence relic to kind of be part of their latest and greatest equipment that they had on site, so that they could compare and they could get definitive numbers on how good is this machine performing to the latest and greatest technology, which then allowed them to make some strategic CapEx decisions on new machines.
Does anybody else have anything that they want to add on that audience question before I move on?
I'll probably add a point on, like everyone else in this group, I'm sure we've all had a chance to do these upgrades and convert from an old legacy system to a modern system. So you always wary that on day when you hit the start button, you don't break something that used to work, right? But I think as the advice that I would give to the question was, as you look at what do you need and how what's some of the advice as you look at planning your new control system or your upgrade, don't get caught in the trap of getting a fancy new control system, but using the old legacy control philosophy. Because that's sometimes what I see is that, we put in a brand new PLC with all the bells, functions, and whistles, a new SCADA system, but then we download the old control philosophy. And then what happens is, you're almost less efficient because, you spent a lot of money, your return on investments now being pushed out. So as an engineer, I would say sit down and sit down with your plant and with your production facility and with your manager and understand, what are the goals and what do we want to achieve out of this production line? Do we want to increase it by 5% or 10%? Is there a sustainability goal? What do we need to achieve? And I think if you map out what you want to achieve, you then look back at your control system and you understand what is the hardware you need to put in place. And then you can look at what your upgrade needs to be in terms of a sequence.
Anything else in terms of what companies should be thinking about as they assess their needs for an upgrade?
Well, actually, they should be thinking about us.
Absolutely.
But well, seriously, on our side, well, I've got two things maybe I'd like to add. You know, beside offering stability or parts availability or reliability, customers should make sure that when they plan their new control system, they plan, well, their new control system needs to provide a lot of connectivity and data availability. Because for now, as Sanjit said, maybe you're just going to do just a simple modernization, but of course you need to be able to harvest the new power of those control systems. So future development and integration will require a lot of data and bandwidth and all those powerful things that reporting tools they require. So I'm not going to say don't be cheap, but plan for the future, because there's going to be a lot of improvement in terms of software, AI, machine learning, and all those nice things. Mm-hmm. Second thing, well, modernization is an interesting challenge in terms of material, programming, scheduling, and management. So qualification, experience, and especially collaboration is of the essence if you want to make sure that your task is carried out with the shortest production interruption. That's yep.
That's good advice. Sanjit, let's change directions here for a minute. I know that you're committed to the impact on the environment and using industrial control systems to drive sustainability. But you know, as we all know, and as we've been talking about today, you know, technology changes really frequently. So, what is really realistic for a manufacturer these days, and how can companies ensure that their systems are sustainable?
So Christina, I am very passionate about sustainability and the environment, and I believe that every single one of us has a part to play in driving sustainability. You know, I can tell you at Schneider Electric, this is at the core of our DNA, both as a manufacturer and a supplier. So it's definitely something we hold close to our heart. So, you know, when I look at the industrial control systems with respect to sustainability, there are so many avenues to consider and so many opportunities to explore to drive sustainability and energy optimization. So if we were to consider just one component in terms of energy optimization or energy saving, which is a common phrase, you know, we can use industrial control systems, and we can use industrial control products such as variable frequency drives in control systems to lower energy consumption, and, you know, typically for fans and pumps. And in some cases, you know, you can realize energy and cost savings between 30 to 50% or more, depending on your application. You know, we can also use industrial control systems to control processes more efficiently and more effectively to reduce waste and also to reduce the carbon footprint. So, you know, I think as manufacturers look at, you know, how do they use industrial control systems to improve sustainability? You know, I would challenge manufacturers and manufacturing facilities is to set yourself goals in terms of sustainability. You know, what do you want to achieve? You know, your carbon footprint reduction. And then have a look back and look at how can your industrial control system get you there. I think for me, you know, many companies should utilize these systems to create an ecosystem that literally goes from one end to the other, and within each spectrum, you know, look at how can we do things more efficiently and more effectively. And in that, there's a lot of savings which come through both from an energy perspective, from a production perspective, from a component perspective, from a raw material perspective, which I think all filters back down into the overall goal of sustainability.
That's true. John, do you have anything that you want to add on that, especially, you know, on the software side and using computer systems, devices, that kind of thing?
The one area that I would kind of challenge users of technology is to kind of put this at the forefront of the things they do. So, for example, if I go to most of my customers' websites, you'll see sustainability as a list of one of their pillars that they talk about as part of the reasons that they do business. But then very often these things fall short of meeting the objectives when you start talking about their control systems. Put this forefront. You know, I remember when I started a big charge around situational awareness in terms of the redesign of how we do HMI and SCADA screens. And one of the first things I would always tell somebody is first identify what your outcomes are. If one of your outcomes is going to be sustainability, then design your systems to achieve it. Design your systems so that you're reporting to the operators the level of energy that are being used so that they can understand when they've used more than was expected. Put that information in front of them. But you can't hold your organization accountable if you don't support them from the initiatives perspective. Put it front and center. Put it out there. The systems are more than capable today of being able to achieve that, but you must be willing, because there's going to be a cost associated with that. Someone's got to design that in. Someone's got to code it up and put those systems together. Not something that can't be done, but very often if those requirements aren't sitting into the documents that are handed off to the teams that are executing, then they simply won't do it by osmosis. You'll have to make sure it's front and center in your thought process.
Yeah, I'm creating a strategy. Does anybody else have anything else that they want to add to that question on sustainability?
I would add to John's point, the awareness of the energy information. We were very surprised that one of our applications, indeed, we were tasked with providing the energy consumption of a piece of equipment, and specifically the focus was on the energy consumption when the machine was in an idle state or when it was not in active production. And you could show somebody that, hey, this machine, while it was idle, consumed 50 kilowatts of energy. You would be shocked at the impact if you said, instead of 50 kilowatts, you said $1,200 in the last 6 hours have been wasted because you didn't appropriately put the machine in an idle state where it went into low energy consumption. So the 50 kilowatts, yeah, okay. But can I relate with that $1,200? That really seemed to have the impact, with the people that were looking at the dashboard.
So I've got a few audience questions here that are kind of related to performance. Robert's asking, how do you manage continuous firmware updating for IIoT devices? Does anybody want to answer that one for him?
Yeah, I can jump in. I think when you look at firmware upgrades for IIoT devices, you want to be careful, in that you don't want it to be automatic updates. You want to make sure you have some level of control as far as the update is concerned, because sometimes it comes down to the state of the equipment that you want to update. You've got to make sure your firmware is compatible. And if I look at the reason why there's always updates, is because as technology is evolving, as we know that the digital transformation is going through different phases in the evolution, you got to make sure that the product is capable in terms of cloud connectivity or in terms of device connectivity. So from that reason, the only way from a manufacturer's perspective is to give the user who has already purchased something maybe a year or 2 or 3 years ago the flexibility to use the latest enhanced features is to actually have firmware uploads. That's probably one of the ways where we take equipment that's 2 years old and modernize it literally by downloading firmware, by allowing it to have the latest flexibility and capability.
So another audience member has asked if moving data directly from the PLC to the cloud is really a great idea without the context of other areas. PLCs tend to have limited scope. So he's asking if there's higher level data management systems that are better for contextual data. I know we had talked a bit about MES. Are there other ones?
So being the software nerd in the bunch, I guess I should jump in here. So one of the things that we have been working on as Aviva is a solution we call Insight. And I don't want to make this commercial because I don't think this is limited to Aviva, but it's a cloud-hosted solution that allows you to push data out there and to model that data, so you can model that data, so you can understand the context with which you need to access that data. So whether your contextual is I'm an operations or I'm a productions or maybe I'm a safety individual, I can pull that context out of that and I can leverage that. Again, I don't have to have direct access to the control system, so it's secure, right? So my control systems aren't going to be necessarily in any way compromised by me doing this, and it facilitates that information across the organization. We're seeing more and more customers may even take that information and put it on their website. Like if I'm a customer that produces water, and they may show like, hey, where's my Clearwell level right there on my website, and that's accessible for all to see. For taking that information and pushing it around an organization is something that is starting to facilitate so many people. Whereas production data typically was frontline operations. Yeah, they need it. That's absolutely important to them. But we're starting to see that access to that information is shortening decision cycles. Decisions that may be being made on a quarterly basis and have to be made on a daily or even an hourly basis. And you can see that in cases of some customers who are pricing their products and their components. And sometimes every 15 minutes they change their prices, and depending on their industries. So much of the aspect of that entire business needs to be nimble. And we're not going to have it hit in the entire business hitting that PLC. That just makes absolutely no sense.
Hmm. Okay, well, we've got a couple minutes here before we go to the break, so I'm going to just close off. I mean, we've talked a lot about controls, their energy consumption, and some specific applications. So what about the C-suite? What do they need to see in terms of a controls project to calculate cost versus value and ultimately ensure that they're making a profitable decision? Vic, maybe you could start us off on that one.
Sure. So in my experience, I've seen several things put on the table to analyze cost versus value. From a control system upgrade perspective, for example, whether replacement hardware is available for the existing legacy system or not, the difficulty in finding professional resources to support the system is also a big factor to ensure, extended production downtime is avoided. Because if you have a problem and you can't get parts, you've got a significant problem. And senior control decision makers typically consider and want to see a variety of factors before making their decision. One, today there is more focus on control systems integration and ease and capabilities, allowing access and sharing of data within the control system landscape. The ability of the control system to intelligently communicate to associated control products, whether they're simple push buttons or pilot lights or sensors, circuit breakers, UPSs, motion control, things of that nature, and thus lowering the total cost of the overall control system while providing a quantum leap in the diagnostics. The ease of transporting data to external databases, whether on-prem or on cloud, that's in many cases a consideration. Not that they may invoke it today, but they want that capability for the future. They realize there's some value in that data. And this is really future-proofing the control system and making sure it will accommodate Industry 4.0, Industry 5.0, and beyond. Also, from a control system functionality perspective, we see increased requirements for things such as ability to do poka-yoke or error proofing, calculating and providing visibility to cell or production line KPIs, as well as a higher level of in-production quality monitoring. So, when they're looking at making a decision, are these things on the table for their consideration? As well, an overall strategy or roadmap on how the controls project can leverage all the current and potential future technology, even though it may not be immediately implemented. So these are some of the components that we see that, typically decision makers kind of look at or ask, what would the system give me in this regards and that regards? And 5 years out, am I going to be changing this control system again? What future proofing is there in it?
Okay, thank you. Christian, what have you experienced as you're working with manufacturers to integrate these systems? What does the C-suite need to see?
Well, it's a really good question, because when you deal with a standard control projects, then you'll probably be looking for ROI of 2 years, depending on the type of business you have. But what we like to sometimes I wear the hat of an association, and when I give presentation, what I want to bring people's attention to is kind of a different approach when you're doing a big transformation. So again, it's a transformation, so it can be 4.0 or whatever, but when you're transforming, it's often hard to come up with an aggressive ROI. So it's much more going to be on the 4 or 5 numbers. So what we like to shed light on is the collateral benefit of digitalization. So this sounds pretty great. You know, sometimes direct cost benefit are not enough to make a project to go. But if you take a step back, automation, digitalization, 4.0, IoT, you know, call it what you want, but this can definitely help in different ways, such as employee attraction and retention, quality control, production prediction, preventive maintenance. So yes, if you go to production and you ask for a budget to improve your machine, maybe you're not going to have enough money. But if you go to see quality, if you go see HR, if you go see production, if you go see maintenance, maybe you're going to chip in some money. So, and in the end, maybe you're not going to hit your 2.2 ROI target, but still, you got to convince your C-level, or C-level will be convinced with, okay, it's a transformation. So I'm going to be in much better days later on. So my point is, initially, your project may not be profitable in itself, but if you consider integrating it into your big picture, then it takes a lot more value.
Mm-hmm. So, and you know, Christina, you know, I'd like to add on this because, you know, we see a lot of this in our business, especially when we're talking to the C-suite and some of our larger projects, is the need to talk about sustainability. You know, we see this being a very common theme at the C-suite today, where, you know, when we're talking about big projects and we're talking to our customers, I think we, you know, the C-suite players want to see what is the return on investment. Yes, very important, but also how is, you know, industrial control systems allowing them to meet their sustainability goals. You know, we know if you look at the bigger companies and bigger organizations, you know, not just in Canada but globally, I think there's been a commitment at the C-suite to have sustainability goals. And I think part of the return on investment, not necessarily from a monetary perspective, but from a you know, from a corporate social responsibility perspective and from an environment perspective, I think C-suite is very interested to understand what is the sustainability goals that can be achieved. And I think a lot of the times that's where you find that, you know, they could be a little bit more flexible in terms of cost. You know, maybe they're going to be a little bit more flexible in terms of the ROI from a monetary perspective. They know they're going to achieve a sustainability goal. So I think we see a lot of that coming into play nowadays.
Want to know who we are? Let's start here. We do this, that, and we make all of these. We're here to connect and power just about everything around you. We help you save energy. We're not trying to save the world, but we are making the most of our energy and resources and making access to energy and digital basic human rights. Life is on.
So for our third segment here, we're going to delve into optimizing performance using data. So Sanjit, let's get the ball rolling with you. What are the limitations of traditional data collection methods like PLCs on the shop floor as we are heading into Industry 4.0?
So I think, Christina, you know, when we look at optimizing data, I think as part of that, you know, we need to look at how, you know, of optimizing the actual process to collect the data. You know, because I think that's a big part of the entire data process, the data capturing process. You know, if you look at the conventional method, you know, you'd have devices in the plant and thousands and thousands and thousands of control cables and wiring running throughout your plant, which on its own was a nightmare to manage. If you look at, and believe it or not, most plants still have the outdated data collection processes of the hardwire. You know, if you look at the modern impact today with industrial control systems and control devices, we have a lot more connected devices, and we have more Wi-Fi or sort of technology-enabled devices, which allows seamless data collection. So I think that's the first part, is to understand how do we optimize collecting data. And once we collect the data, what do we do with it? So, you know, so today, obviously, you know, we looked at how we can use PLCs and we collect the data. But I think a big part of what we see in industry today is that once the data is collected, one of the biggest limitations is the way data is being used. It's still being used more from a visual or graphic representation, which if you go back to, to Vic's analogy of, having the blue-green little icons that come in and out of your screen, so I think that's a big part of what people are using it for today, which to me is maybe a percentage of what you could do with the data once it's connected. So, if I look at data optimization, I look at what can we do and what are the platforms and what are the tools. Collecting into the PLC is one step, but we now need to interrogate the data, and this is where we look at software platforms typically, and this is where we look at companies like Aviva that have the platforms that allow us to interrogate the data. I believe there's a big shift in data optimization today, moving away from just the visual optimization to actually predictive and preventative data optimization. And if I take a step back and if I look at the technology between devices, connected devices, if I look at the PLC hardware architecture supplied by Schneider Electric, if I combine that with the software packages that typically Aviva have today, it's almost a power suite of data optimization tools, and I think the possibilities are limitless.
Christian, how about you? What are you finding in terms of the data collection methods on the shop floor heading into Industry 4.0? What do you see in terms of challenges?
Well, Sanjit, you said it pretty much half of my answer. But well, actually, so that's the soft. Well, the product side. If I go on the integration side, so if I speak for ourselves, what we find the limitations is simple. It's complexity. You can always find or actually develop a way to extract data from an old control system or a PLC. And even if there is no control system, as Vic mentioned, if you have an old blow molding machine for a plastic or whatever, that is built in the 60s, you can still attach a PLC and then extract data. So there's always a way. Today, the difference, and again, as I mentioned before, today the trick is the user experience, and it can be in terms of programmer or integrator or end user. It has to be easy, it has to be fast and efficient. With the amount of data that will be flowing, you need to have the proper tools to dive into those, or to mine into those data and extract some valuable information. So again, the product that are being on the market today, compared to the previous one, simple. They are easy, they are fast, and are efficient. They can handle a lot of amount of information.
Yeah, Christina, some of the limitations that we found. I recall not that long ago, a client wanted data extraction from his existing PLC infrastructure. And I would say 50% of the PLCs had RS-232 ports. And that was the only way to get data out. And we tried as hard as possible to say, look, you're going to invest so much money in just trying to optimize getting data out at 9600 baud on a good day with no errors, et cetera, et cetera. Why don't you take that, investment and just upgrade the infrastructure? Today, you could plug in multiple Ethernet cables and have no impact to the PLC scan time, because to service the communication port in the old days, it was one processor and it had to do everything. So, some of the limitations are people still wanting to, no, we've got a PLC. We just want to do this and this and this with data and get data out. And, sometimes you got to be blunt, as, the money's going into the wrong direction. So that's a limitation we've come across.
Sorry, go ahead.
I just add one thing to consider here is that when you start about limitations of traditional data collection methods, I think one of the biggest limitations we have is sometimes in our own imagination. And what I mean by that is that maybe the best place to get that data is not the PLC. Let's say, for example, if you think about what the operator's trying to do, the operator sees that there's a falling output pressure on a pump and he knows a seal needs to be replaced. When's the last time that thing was maintained? That information is not in the PLC. Do we have any spares in inventory? That information is not in the PLC. When you start looking at ourselves, I think often the biggest limitations we have are just the assumptions that we're going to getting data from the PLC, and that's how we're going to be building all the operator experiences, when many of the things that he or she may need to accomplish may not be there at all.
And I mean, do you feel that that resistance is because of not wanting to have to learn a new technology, or what is it exactly that would make somebody want to use such an archaic device, Vic, like you were talking about, and not make that that jump? What is the reason?
Again, they don't have the forward thinking that says best use of our financial resources today is to invest in the future, to keep investing in this old technology. And I'm sure the PLC has worked fine. It'll probably work fine for another 5 or 10 years, just because they're robustly built and meant for an extended life cycle. But when you're piling money into the old and not just biting the bullet and say, there's a lot to gain by putting a new controller on there with the latest and greatest in communication capabilities. It's just that mindset. That's the only thing I can attribute it to. I mean, we try our darnest to make them realize that, their money is going into the wrong, avenue. But what can I tell you? No. We want to keep the existing infrastructure.
Yeah.
Again, as I mentioned before, sometimes you'll have veterans that are able to make it work. So your RS-232 port, there's somebody that's going to be very, very happy to come up with the project of developing a driver specific for that. Actually, this guy is pleasing himself.
Yes.
He is not pleasing his company. So he is kind of encouraging this legacy thing, where actually we have to be thinking forward. Vic, you're definitely right on that. So you're investing your time and effort in the past while the train is still moving on, and you're kind of not watching it, but you're not even looking at it. So you got to jump into it and invest on things that, of course, are sustainable. Again, what Sanjit was mentioning, RS-232, it's not sustainable. Ethernet is, Wi-Fi is.
Yeah, and Christian, to your point, it could very much well be the comfort area of those individuals. I've been working on this system for the last 10 years, 15 years. I know it inside out. I'm good with it. Let's just keep it and get it to, move forward, instead of, at some point you have to do a rip and replace. There's no option when the technology becomes so old.
And actually, just to play along with you, Vic, you are good at working on this old machine, but you are the only one. So as soon as you are retiring or whatever, you're gone with the knowledge. So knowledge today needs to be owned by the company, not by an individual, which is a little bit of the philosophy behind MES, which I was talking earlier. But those new technology, they need to be owned by the company or not the employee itself.
Yeah, and I think part of that, to that point, Christian, is that I think a lot of the the veterans, as you so call them, sometimes people use this as a means of job security. If it's a 20-year-old machine and you have the one guy that can look after the machine, there's some form of job security in there as well. So I think I love the forward thinking comment, and I think in an ideal world it would be an easy decision, right?
Mm-hmm. Yeah, well, I mean, if this year has taught us anything, it's that we really do need a contingency plan. So you can't operate that way where one person knows how to do the task at hand. where do edge and cloud computing fit into the controls architecture? We hear a lot about these terms in the industry for some SMEs who are still not quite there yet. I'm wondering if, John, maybe you could talk to us about how edge and cloud enable real-time optimization and getting that visibility into what's happening on the shop floor.
Sure. I think it's somewhat of a continuation of a discussion we had earlier where I was talking about functional separation. Edge is, in the past, we had a lot of traditional technologies. We didn't call them edge, but they were PLCs. Those are edge computing devices. Industrial control panels, edge computing devices. We're seeing an introduction of more and more. We're starting to see smart sensors and other types of gateway type devices that sit out there at the edge. But those are all things that are often very much responsible for safe and effective control. And it's of utmost importance that those things be secured. And in many times, security often means that I'm going to be willing to take less functionality in order to maintain security. Now, when you look in cloud, clearly, I'm not suggesting that cloud in any way is not going to have the same intentions of security, but I don't believe it has the trust. So a lot of people won't trust the aspect of cloud, but they will look at it and see, well, things that won't affect either my safety or my ability to effectively control this situation here, things like if I'm going to do optimization or I'm going to do efficiency or some sort of empowerment capability. So if I'm going to be doing something outside of that system, like identify an anomaly detection, how do I then later report that anomaly detection back into the system? That's when we tend to call it hybrid, right? So the hybrid systems where I'm going to take information from that cloud system, leverage it in that edge system together to build a stronger system together with that functional separation to ensure that none of the integrity or safety of that system is compromised.
Okay. Vic, maybe I'll turn to you on that one. When it comes to MES especially, how do edge and cloud fit in?
Yeah, certainly. So, we look at the optimization of the process. That's core. I mean, that's the whole purpose of getting all that data. And once you have the data, you drive the data analysis, data modeling, correlation analysis, statistical process control, simulation, all can bring forward, high value, significant insights to optimize production in real time. Many of these computational forms, are just, too complex to be done at the edge. So you take the data, you move it out into some database, you run the algorithms, and then you feed back into the edge the optimal set points that are going to ensure either optimum quality or maximum utilization of the asset, et cetera, et cetera. So the data goes out, you do the heavy lifting as far as the analysis and the data crunching, and then you come back to the edge to actually make an impact on the actual process.
John, we're missing your camera feed here. I'm not sure if it got turned off accidentally. I just want to
I'm trying desperately to turn it back on.
Okay, he's still with us though, so no worries there. We have a couple audience questions, so I'm gonna turn to those just while we wait for that. Stephanie's asking how you foster that future-looking mindset that you guys were talking about in customers and also in internal leadership.
Yeah. So I think it's about creating a vision, inside your company, inside your organization, inside your department. So I think, as we create this culture of forward-looking, I think a part of it comes from the individual, from the employee, wanting to do the right thing. To Vic's point, you want to do the right thing for your company, not necessarily what's the best thing for yourself. But I also think it comes down, it's a responsibility of leaders and of the company is to set the vision and set the direction of where they want to go. And part of that is making the investments that's needed to support some of these upgrades, some of these forward-thinking initiatives that would come into place. Because one of the other things we see is that there might be a machine that's ready for upgrade, or there might be a better technology, but from a management perspective or from a company budgeting perspective, the technician or the engineer on the field doesn't get that budget allocation to put forward the new upgrade or the new technology that might be needed. So I think it's in summary for me, I think it's dual purpose. Part of it is it's the employee himself who sometimes needs to want to do the right thing for the company and be forward thinking and also improve himself and his technology skills. But I think the other part is probably the bigger part is that it's important for the company and the leaders within a company to create that vision and create that message that we need to look where we are today and where do we want to go in the future.
Yeah, good point, Sanjit. One of the things we also do is we foster blueprinting sessions. And so when there is a control system or an upgrade or a new process, we foster discussions with operations and the business people and share with them, this is the technology today, and this is what you can have to help them formulate that vision. Sometimes they're just not in touch enough with what can be had to really make some of those decisions. So we kind of help them. And then we also drive a roadmap, if you will. So having the ultimate vision is fantastic, to be able to get agreement that at some point in time, this is what we need to achieve. These are the business goals that we need to accomplish. And then we start from day one. And we kind of break it up over, it could be a 6-month, it could be a 2-year time frame with milestones, so that not only do they have an awareness of what's going to be done today and what's going to be accomplished, but as we move forward, the upticks and the benefits that they're going to be able to extract from their local control system. And that also helps justify, somebody says, well, why do I need a PLC with 2 Ethernet ports on it? Why am I paying the extra premium for that communication capability? But when you show them a roadmap of, today we're using one network for this purpose. Tomorrow, we're going to use the secondary network for this whole other purpose. And so then they start to understand and can easily bite off those, few $1,000s today for huge benefits, tomorrow and into the future.
Okay. I've got it's sort of a general comment from the audience, but I thought it might be interesting to talk about. They say they see a situation where the operator's okay with what there is on SCADA. They know it well. They've achieved nameplate or even better. And why add more data or invest in new technology? And they say that the data, having the data to the PLC from the current instruments is enough.
I can certainly add, a comment to that, in that we have a client that's trying to, they make in excess of 1 million donuts a day. And there's a certain percentage of those donuts that never make it to the retailer because they're just not suitable. And when you look at making 1 million donuts a day, you would be surprised at the amount of wastage that actually goes to livestock feed. And when you look at the process and you look at the data from that process, everything seems okay, but obviously something's going wrong, because there are a fair amount of rejections throughout this process. And in many cases, we strategize with the process guys and say, there's something missing here. There's nothing you could put your finger on when you look at all the process parameters that should justify why we just scrapped 80 pounds of bad donuts. So obviously we need more data. And this is where IIoT devices are fantastic, because we can go to an oven, or we can go to a deep fryer, and we can add these sensors quickly in a day. Well, I say no wiring, but minimal wiring. We just power it up, and you just apply it to the specific area where you need to know a temperature or humidity, and boom, within 10 minutes, you have that information coming into the control system. I think, I'm not sure if it's Christian or Sanjit, that you don't have to run a conduit back to the PLC and bring wires out and power wires, signal wires. No, you just, almost like a stick-on, you stick your your IIoT device. Some of them even have batteries that last for weeks and months. And within 10 minutes, boom, you now have visibility and data collection of all these extra points. Now you can at least, now you have a data set that is hopefully wide enough that you can start to see and identify anomalies that identify why we just put 80 pounds of donuts into the waste.
Yeah, okay. I mean, you kind of touched a little bit there on my next question here, which is the current trend when it comes to connectivity of control systems. You've talked about Ethernet. I know single pair Ethernet is kind of gaining some traction. I'm curious about what's the next big thing or the thing that's big right now, and if that's going to continue in the future. Maybe Christian, you can start us off with that.
Well, nice trend that we like to see, of course, is the capability of system being able to work together. So what we've seen before is, we had a lot of protocol that were being used in the I would call it the office floor. Such as SQL or MQTT or OPCs. And now all those nice features are being seen directly into the PLCs. So this is pretty interesting because it accelerates the integration jobs when it comes to linking PLCs and reporting softwares and stuff like that. So my point is, for developers today, communication protocol, they really need to be open. You need to have the possibility to connect any type of controllers. Would it be Ethernet or Wi-Fi enabled, as we said? Of course, security is a major concern, but well, for that, I guess we're gonna chat about this subject in a few moments. But yes, I'm sure there's gonna be, we are just at the verge of the new level of integration softwares. So lots of data coming in, lots of analysis tools coming out of AI and machine learning. So yeah, there's some pretty nice trends that are coming.
So just while John's continuing to get set up there, does anybody else want to jump in on the connectivity of control systems and what's the big trend right now?
Yeah, I can go on this one, Christina. So I think, if you look at the evolving trend when it comes to control systems, I think, the underlying or the underpinning feature or characteristic that a lot of the clients are looking for now is speed. How quickly can I get the data? Because real-time computing, real-time data acquisition is really what people want to see. Especially if you take a step back and if you look at typically machine analysis. If from a manufacturer perspective or from a analyst perspective, you want to be able to look at a component failure and know the second of the minute of the day when that failed. And in order to get that right level of accuracy on the data, that means you got to have real-time data transmission. So I think when people look at protocols today, I think speed is one of the most essential items that they look at. And we also see a developing trend where a lot of plants are no longer levitating to a single protocol. We see a lot of companies asking for open protocol. We see a lot of companies asking for dual protocol. Where even on the single cable, you want to be able to have two protocols running on a single cable. So we see the evolution go through, and again, it still comes back into the speed and to the data packets that go through within the protocols.
Okay, I'm gonna move on to the next question here. What capabilities are available for industrial control systems in the prediction and modeling of data? Sanjith, I'll come back to you on this one first, and then we can move on to somebody else.
Okay, so I think from prediction and modeling, if we take a step back, and I think the common theme across the entire discussion today has been productivity and uptime, and keeping machines going. Especially as we went through through the crisis, and as we look at every day, and as we look forward, it's always more productivity, more sustainability. How do we do more? And if I look at it from that perspective, we know that downtime costs you dollars. For every hour or every minute that you're not running a production line, that means you're not producing, that means your efficiency goes down. If I look at prediction software, and I look at modeling software, and and modeling of data, it really helps bridge some of those gaps. Today, there's modeling software where you could literally commission an entire line, right at your desktop, sitting in your office, or even sitting in your lounge. You get your little laptop, you commission it, you do all the modeling software, you test it, you debug it before you even get to the production line. So, if you went 5, 10, 20 years back, some of these commissioning of lines and upgrades, could take you weeks, months, sometimes several months. Now, the norm or the benchmark is to have commissioning done in a matter of days, if not weeks. And modeling allows you to achieve that. So that is one of the big capabilities. If I take the step forward and say, once you're in production and you're running, you want to now look at the prediction. No more. So if I look at planned maintenance is now a thing of the past. It's now predictive maintenance, and it's prescriptive maintenance, because you want the data to be used to actually tell you when a failure is going to occur. And then if we take a step forward in terms of the prescriptive, the data needs to tell you what to do to prevent the failure. So for me, if I look at industrial control systems and if I look at the capabilities, I think it's limitless. I think it comes down to 2 key components. 1, the hardware that you put in place, and 2, your limitation of your imagination and understanding what you want to achieve out of your software and control system.
Vic, I'll turn to you next on that one. What capabilities are available for control systems in terms of the modeling of data?
Yeah, I would say that modern day control systems allow information to be modeled, because it can be contextualized. You can have extensive definitions with your data, so that you now have the ability to describe the data, describe devices, machines, lines, even the plant, all part of the data. So instead of getting a 1 or a 0 from a sensor, I now still get the 1 or a 0, but I get a timestamp. I get information that sensor is on, the 3rd production line underneath the robot, and sensing whether an axle has arrived or not arrived. So now I have all of this data that comes to me, whereas in the old days it's a 1 or it's a 0, and that's it. And I didn't have all that additional background, that I could start doing an analysis and better understand really what's going on here. So, I would have to say, with the hardware predominantly, with controllers now being able to provide that, it really brings extended value to the control system, the process, and the business.
John, I know you missed a little bit of that, but if there's anything that you wanted to add in terms of modeling of data, and I believe we were chatting about the connectivity of control systems, feel free to jump in.
Well, we definitely, I think Vic is already making the point, is that the systems now are getting more intelligent, right? Where when I began in this industry, I'd be lucky enough if I was able to identify what register the information was being held in, right? Now you're getting a lot of verbose information. I'm able to get the limits or anything. I might be able to have everything I need to stand up the systems north of that, to be able to create the data elements, to be able to identify where I'm going to store the information. All this information is there, because as engineers, I know for myself, if you told me the tag name of anything, I could tell you. I could tell you what wires it was on. I could tell you what conduit runs it was in. I could tell you everything based on that. And you can utilize that information that you're getting from these assets to dynamically assemble everything from visualization to analytics. And there's so much of it that can be done. And so as we start getting more information pushed from the edge to the systems themselves will be much easier to maintain, much easier to expand, because in the past, systems were very much set it and forget it. I'm going to put this system in, I'm going to go through the factory acceptance test, and then no one's going to touch it unless they get approval to touch it. Now we find systems that are living and breathing, things that we're constantly commissioning new things, decommissioning old things, and this will make that job way easier.
Mm. Okay, I'm just going to wrap up this segment, hopefully somewhat quickly, although it's a big topic. I'm curious to know, we're hearing a lot about 5G, obviously, as consumers, but also in the industry itself and what it means for manufacturing. So I'm wondering if you could kind of give a brief overview of what role you think 5G is going to play as it sort of rolls out into industrial spaces. Vic, maybe you could start with that one.
Sure. So just quickly, I think 5G is going to foster manufacturing getting to the next level of industrial revolution. In essence, most transactions will be in real time with large data payloads. And it's going to make things like augmented and virtual reality to assist operations and maintenance a panacea. Lower latency, increased capacity, higher data speeds will all accelerate achieving smart factories.
John, do you want to jump in on the 5G chat?
So if I look at where I believe the impacts will be happening first, I think it'll happen in those particular processes and operations that tend to be geographically distributed. Today, it's pretty common in those applications that people have to stand up their own radio towers, or they have to lease lines out of satellite networks. And now suddenly they're able to piggyback on public networks with higher data fidelity, add more devices at a lower cost than what they were doing before. This will create a step change. And so for those systems today, when they may be happy to get data once every 15 minutes, now they're able to get that data every second, and it's going to be lower cost for them overall. And they're going to have more instrumentation. The other angle of that is not so much data connecting to the systems, but people connecting to systems. So in the past, I've seen a lot of organizations where, they won't have wireless devices because they don't stand up wireless networks on the control networks, and they're not even going to have wireless networks out there. So you can have your handheld device, but there's nothing you can connect to when you're on the production floor. But that's the other aspect of 5G, is that it'll make ubiquitous access back to the people, so that those devices are having. So if I'm not standing in front of that thing clad in stainless steel that's my entry point into the system, I can now use the one that's in my pocket.
So we're coming to the final segment here, securing industrial control systems. So we're going to kick off discussion with Sanjit. Why is security a problem in industrial control now in 2020?
So great topic. I think one of the biggest threats that face industrial facilities today, especially when it comes to essential services like water, wastewater, water treatment plants, is the threat of cyber attacks. It's a growing trend. It's rapidly increasing. If we look at cyber bandits, if that's what we call them today, I think they're opportunists, and then we see a growing trend where they hack into control systems and they lock out either a water treatment plant, or they will lock out an essential service. And then they hold either the municipality or the customer ransom for X amount of dollars before they can open it up again. So I think cybersecurity is it's definitely something that I don't see people taking seriously enough. I think there's this lackadaisical thought process that it's not going to happen to me, or I'm in an industrial sector, no one's going to come and touch my little factory. But the reality is, once you get locked down and you're locked out of your production facility, no matter how big or how small, you could go days, weeks, before you can open it up. And what it could mean is, as opposed to paying maybe $10, $20, $50,000 cybersecurity analysis or software point, you'd now have to pay $1 million to either get someone to come in and upgrade your line, because all your hardware is now useless because it's just been hacked. Your line's down, your production's down. So I see this becoming a threat. But I think what's a bigger threat is that I do not see consumers taking cyber security or cyber attacks seriously enough. I think that is adding to the strength that cyber bandits have, and I really think we need to start thinking about what does this mean, and what does it mean to our plant, and what does it mean to our customers. That if I were to get locked out of my plant today, what would that cost me? And is that cost greater or less than what it would be for me to actually invest in having a good cybersecurity plan?
Okay. Christian, I'm going to move to you. If you have anything that you want to mention about cybersecurity.
Yes. Unfortunately, well, I'm really behind you, Sanjit. Unfortunately, the majority of incidents are kept undisclosed. So
Yeah.
personally, I heard maybe 4 incidents, on my job sites, and one of them stopped production for 3 days on 6 sites. Seriously. Another one caused the whole company to stop function maybe 2-3 weeks, from customer service to production floor, going through financials. And this around the world. It's not a small thing. But the problem is that all those incidents, of course, were kept as secret as possible to avoid damaging the image of the company. So in the end, it causes other customers to have a distorted picture of the real situation or a potential threat. So they don't assess the risk as they should be. But it really is. And if you ask those customers that lost production, I'm telling you, it's a major crisis. So again, people don't know the tip of the iceberg of those threats.
Absolutely, and if I look at our business inside of Schneider Electric, it's such a big topic. It's such a threat globally that Schneider today has a division that looks after cybersecurity in terms of working with our customers and working with the infrastructure and putting in the necessary cybersecurity and assessments and cybersecurity measures to ensure that we protect our customers' data and their hardware.
And Christina, as well, we should be aware that human safety is also at risk here, right? Because when a system is attacked, we don't know how the process, we don't know the outcome of the process and what the whole production line is going to do, and so it can certainly present risk, to human life, depending on who you are, where you are, and what the process is.
Yeah, we're seeing some of that with OT devices getting in there and making the machines move differently. I think that's what you're getting at, yeah?
Yep.
Yeah.
When we discuss, why is it a problem? I think we probably all kind of have some basic understanding of what the implications could be of not doing it, but how do we get ourselves here? And we were talking earlier about systems being in I called it a set it and forget it situation. Put it in, let it go. We'll see things that are run sometimes decades. I can tell you a decade ago, the methods by which somebody was going to attack something were not known today, right, in terms of what they are today. And things change, and the landscape and security changes so quickly, and you have to be nimble to change. But you remember we talked earlier about what it takes to kind of get a system to upgrade? What's it going to take to be able to convince someone to spend the time to introduce the risk to their operations to upgrade? And I think what some of my colleagues have already identified here, a lot of people sit there and say, I don't know that I can balance that risk against availability until it hits them. And then they realize how important it was.
Mm-hmm. Yeah, and by then it's usually a little too late. As a follow-up to that, what are some of the potential consequences if an industrial control system is hacked? Beyond, we talked about the OT piece, but what else can happen, Christian?
Well, that's a very good question and a very good follow-up on the previous question. Personally, I think all the consequences can all be categorized as one word: losses. As I said, the viruses have always been a pain on the office floor. They could create problems which had, of course, unfortunate consequences. And still, those consequences were limited to software damages. But as Vic mentioned, now when the virus spread to the production floor, it's totally different. The consequences are definitely unlimited. We're talking about direct physical implications. So we're talking about production stopped for, again, as we said, undetermined period, which can be very long. You will lose trust, between your customers, your suppliers, your contractors, and your employees. You will begin to lose trust. You definitely can lose intellectual property, but last but not the least, lives. If you're considering where ICS are used today, such as in nuclear power plant, water treatment, electricity, heavy lifting, and so on, of course, I think we can all grasp the potential danger of being hacked.
Sanjit, do you have anything you want to add to that piece?
Yeah, I think Christian and Vic covered it really well. But I think the one thing I would add is that one of the potential consequences, it could cause companies to close down. Depending on the size of the company, depending on the level of the cyber attack. If a company just doesn't have that, the bandwidth or the investment available now to get someone in and get this redone and to take them out of the crisis, it could have effects where you actually find companies would close their doors. So I really think it's something that I encourage manufacturers to really look at their plants, look at where their risk lies, and make a fair assessment. What does that mean from the plant perspective, but also what does it mean from your people perspective?
So, I mean, what are some of the areas that manufacturers should be mindful of when it comes to attacks? Are there common entry points, John, that you could maybe highlight people should be thinking about?
In recent publications documenting cases of cybersecurity issues with industrial control systems, it was indicated that 100% of the clients believed falsely that their systems were air-gapped. And a lot of times what happens is that they were just not aware of the risk that was posed to them. I mean, it's amazing when you sit there, but 100% of these cases, they think, well, wait a minute, I'm secure. My systems are air-gapped. And I can tell you from personal experience where someone's told me their systems are air-gapped and then show me later a remote desktop into the application. Like, well, how did you do? Wait a minute. Well, how'd that? And so I think the case here is first thing you have to do is be honest with yourself. Be honest with yourself about understanding the topology, establishing that threat model. The threat model basically, first of all, goes through making sure you have a clear and documented topology of your system so that you understand what the attack vectors are. Because I think right now what happens is so often, and it was clearly identified in this response that I had read, we had the wrong impression of a security burn.
I think when you look at cybersecurity, there's various levels of entry and there's various levels of risk. I think what manufacturers really need to be mindful for, or the best practice is to bring in a company that's experienced in looking at your hardware, looking at your infrastructure, and looking at your ecosystem, and then giving you a true assessment. Because you find that if you try to do that on your own, and you try to do that at the technician or the operator or the plant, or even your IT department viewpoint, you're gonna look at it very subjectively. You might have tunnel vision, and you're not going to look at the broader picture. So sometimes, when it comes to certain topics, it's worth more to actually pay the money, bring in a professional that's seen the various levels of cyber attacks and get a free assessment. And I think that way you cover your risks to some extent.
I've got an audience question here asking about balancing the traditional approach of not connecting your control systems to the internet, which is arguably a little more secure, versus the ease of connecting IoT devices and the increase in security that's required with that. How do you have those conversations with your clients?
I think one way to look at it, and again, I've really loved this discussion, and I've loved my panelists' comments for various questions, because there's a common theme, right? Again, if I look at what Vic initially said, let's be forward thinking. If we don't do something because we're worried about the risk of typically what could happen, then we're never going to move forward. I think if you look at connectivity, and if you look at connecting your industrial control systems and the best practices, I think you need to move forward, but then mitigate your risk, because we know there is risk. Do the right things, put in the cybersecurity measures in place, but don't hold back. Don't not do the right thing for your company. Don't do the right thing for technology and productivity. Just weigh up your options and assess the risk, and then put in your plan and put in your hardware accordingly.
Anybody else want to jump in on that? I'll move on if not.
The one thing I would say here is that connecting to the internet does not need to be bidirectional. But I would always ask somebody, as outbound only would be our focus. If you want to do something, pushing data to systems so the data can be pushed, but it should always be from internal to external. You should never let a connection from external to internal, never, ever, ever. And so in this particular case, you make sure that when you configure these systems, that all connections originate inside the network. And that's a pretty simple statement, not necessarily the easiest thing to accomplish. And it may make you to make qualitative decisions around what truly is possible and what should I allow and is it necessary. I know we started at the top of this conversation about what was one of the biggest challenges that was brought on by the pandemic, and it was remote access. And so now we're kind of sitting here saying, well, be careful with remote access. It's valuable. It's absolutely extremely valuable, but it could also be very dangerous if applied incorrectly. So you have to take a measure of caution as you apply the systems and deploy them.
Mm-hmm. Yeah, just to dig a little bit deeper into that, I mean, what specifically should manufacturers be concerned of in terms of security when it comes to giving workers remote access? Vic, maybe you could weigh in on that one.
Sure. So the access, must be well protected. It must have encryption, authentication, to restrict user activity to predefined areas. Things like malware, or even connecting a USB stick, to the remote computer that's on the company network, can compromise data and can compromise the whole system. And, clearly, we should not be allowing connection of personal devices, to our company networks. Most of the companies we deal with, if we're going to be connecting to their infrastructure, they will send us a laptop, their laptop, which is well protected, where all of the ports have been disabled, so you can't plug in a USB stick, and you can't load any kind of software, because you never know where the malware is coming from. So remote access is excellent, but there's got to be a lot of caution and a lot of precautions all around it. And in some cases, organizations, have to look at and have to deploy industrial demilitarized zones, allowing, the interconnection of their networks with disparate security requirements, to protect the shop floor. Security standards have been around for, a long time. NIST cybersecurity framework, NERC, etc. So the industrial control system ecosystem just has to prioritize security, before the lack of becomes a greater problem. As well, in regards to remote workers, your traditional remote office worker, okay. But once we look at, industrial control professionals, once the security's out of the way, one also has to consider the human error aspect to remote access. Mistakes on an industrial control system can have costly and significant impacts to the operations, whether it's the incorrect configuration, set points, PLC SCADA programming errors, and they're going to be a bit more difficult to identify from and by a remote user, just due to lack of, the physical world not being visual for them, right? So there's a lot of considerations when we go remote for industrial control systems.
Mm-hmm. Christian, how about you? What do you think that manufacturers should be concerned about in terms of remote access security?
Really love your answer, Vic. Christina, I have one word for that, I think, and it's trust. Of course, as Vic says, you need all the bells and whistles to be able to secure your network, limiting access only to the work to be done, have those remote workers sensitized and trained on potential threat, have them sign papers, put epoxy on ports, putting multiple firewalls. This technology is essential to have the basic security. What I like to put emphasis on is trust. You can do a lot of things, but in the end, one cannot grant access to sensible controls without establishing a proper relation with the remote worker. We were talking earlier with sustainable things in terms of industrial automation. Being an integrator, I'd like to make a parallel with making a sustainable relationship, and I guess you see where I'm getting at. If you want to keep doing VPN into your customer, you got to be clear, and you got to be knowing each other, collaborate together in order to make sure that there is no loopholes in terms of security. You got to be able. It can be as as strange as make sure your employees are well paid, because somebody will pay much more to hack your system. So there's a human factor in this that needs to be considered on top or below, whatever you want to put it, of all the necessary technical security features that you need to put in place.
I've got an audience question here. Are there any checks and balances in determining if a manufacturer is selling a safe product? They're mentioning a specific controller. I'm not going to name the name, but they're saying that it's widely used in plants and it's not necessarily safe. Is there anything to watch out for, when you're considering new technologies to implement into your plant?
Well, I can just throw a couple of words here. I've played with some IoT things at my home. Of course, you don't play with that at a customer's. It's very, very hard to make sure that what you have in your hand is totally security or securable. Not to pinpoint any part of the world where parts can be coming from, but you can buy some stuff on internet and it comes to your house, and then first thing you want to plug it into your Wi-Fi. And I've seen stuff as soon as you click enter on your IoT thing and it hooks up to your home Wi-Fi. Right away, your SSID and your password is sent to God knows where. So yeah, sniffing is probably one good thing you can do before you install this, but sniffing is just like the basic. But you gotta work with a company that has a lot to lose if it gets pinned down because it hacked some things.
There's something I can add to that to consider is that there are practices and certifications around the development lifecycle practices, and you can ensure that the organizations that you're working with are part of these. So, there is an IEC 62443, and there are parts that apply to vendors. And those vendors can be certified by independent organizations like an ISA secure organization, which has come in and audited our development practices to ensure that we train everybody and enforce these development practices throughout ours. So very often you have to be somewhat careful. Startups might not have that maturity, right? So if you're working with a startup that might have some brand new fancy technology and it may be really interesting, but very often they haven't gone through the level of maturity where they have established the security practices to ensure that they're ready for prime time. So in this day and age where I see everybody kind of looking at IoT and they're trying everything, they're experimenting with everything, just be aware that make sure that you can go there. It doesn't mean that you shouldn't do that, but you should be able to go to your vendors and ask them to express to you and demonstrate to you that they've achieved these certifications. And if they can't readily do that, be afraid.
Yeah, and John, I would add to that, as a consumer, you always want to make the right choice, and sometimes it's not that easy. But there's telltale signs that you can look at, and I think one of the things is always align to a more reputable manufacturer. Sometimes cheaper is not always better. And
Right.
Sometimes there's a reason something's cheaper. When I look at pricing and I look at the various discussions, and I always look when I look at pricing, even I do this in my personal life. When I buy things for my home, I always look at it and say, well, there's a reason that this is $10 more expensive. And I look at it. Sometimes it's the brand. Sometimes it's the fact that if it fails, I have someone to hold accountable, right? So these are the things that you need to consider. And I think if the only thing that you look at is price, you might end up in a lot of trouble. To what Christian said, and this to some extent, to a milder version, probably can also show you this is some of the effects of cyber hacking, isn't it? Because the devices allows you to become more vulnerable to these type of things.
Okay, well, I think to close off the cybersecurity discussion, I'd like to know what steps manufacturers can take to ensure they're designing a secure system and that they can identify threats. John, maybe you can start us off on that one.
I mentioned the term earlier, threat modeling. It's a general practice, and it's a structured way of analyzing threats against the system. And it's a general practice. There are tools from Microsoft to facilitate threat modeling on software systems, where in essence, you want to be able to go through an inventory, all software, hardware, document the network topologies and access points into these applications, understand all data flows, and understand how and why they're secure. Again, there are off-the-shelf tools to facilitate this, and there are a lot of vendors out there that can support that. So if you look at this and go, this is outside of my skill set, hire someone. Bring someone in who is in that secure area, because there are companies that facilitate that, but don't just assume it to be true.
Sanjit, how about you?
Yeah, I think John put it perfectly. The best thing that you can do for your facility today is get in the professional amount of people that know what they're talking about, that they can look at things that you would normally not even consider. And call Schneider Electric. This is what we do. We do cybersecurity. But jokes aside, like I said, and John's aware, between Aviva and Schneider, we have dedicated processes and programs in place that actually look at this. And there's documents and books and documents of books and books that these guys are talented and learned towards, in terms of looking at the threats that typically can attack within a plant, and how to actually mitigate some of these risks. So sometimes it pays to actually spread the money and bring in the right people.
Yeah, absolutely. I mean, I think we know from many studies done recently that cybersecurity is really overlooked in organizations, or left to somebody who's not necessarily specialized in the field. So we're getting close to the end of our time here today. So I have a final question that I want to end on, and I thought maybe you could each answer in about 30 seconds to a minute about the latest trend or product in general terms in industrial control that excites you the most going into the next year. Just to end on something good. Christian, let's go to you first.
Well, as I mentioned before, I like the way new PLCs are talking languages that were before only seen in Office software, such as SQL, OPC, and MQTT. So this really elevates the integration level. I love also the way AI has overcome vision problems that before were not possible to resolve with traditional vision system. And also really keen to see new dark warehouses equipped with automated guided vehicles and automated storage and retrieval system. So that's what I'm really interested to see in the next months and years.
Vic, how about you?
So I would say the deployment of artificial intelligence to improve manufacturing, truly creating a smart and conscious factory, leading to a whole intelligent enterprise now. Really an intimate connection between the shop floor and the rest of the organization, and enabling manufacturers to 100% leverage its assets with no waste. Smart factory, an intelligent enterprise, where the production environment is intimately coupled to the enterprise. I think we're heading towards a future where we will have a conscious factories driving the supply chain.
John, going to you.
I think the biggest trend that's exciting me right now is more around the tone that I'm seeing within the customers that I'm working with. And what I mean by that is that, about a decade ago, we had hosted a set of our biggest customers at a Microsoft center, and we're explaining them what Azure and cloud was. And there was clear, not me, not right for my business. And it was a resistance that when you look at industrial automation, we're one of the last organizations to kind of digitize. If you look at retail, man, they went through this a decade ago. And finally, I'm seeing a willingness to take that chance. And that's what I keep talking about earlier when I keep saying segregating functionality, not trying to take these technologies and apply them into mission critical control, which clearly no one is willing to sacrifice the safety and the security of those systems, but are willing to actually look at these hybrid systems that they can pull together. so that we can start looking at, well, how do I pull together augmented reality? How do I pull together artificial intelligence, machine learning, cloud computing? And that is also being ushered in by the unfortunate circumstance that COVID-19 has put us in, where we have to pull people together. I think that is going to create an inflection point where you will see a significant difference in the way people are behaving, not so much because of the availability of technology, but a final willingness to take it and apply it and go forward.
Sanjit, I'm going to turn to you on that one.
Yeah, so I think very similar to what Vic's seeing. The trend that I see today is there's a shift away from buying products. It's more about buying integrated solutions. How does the new component fit into my ecosystem? So the trend is to create ecosystems as opposed to just buy products that stand alone. And in creating the ecosystem, I think you have a connected world, a connected product, a connected factory, which then leads to smart factories and smart manufacturing. So I think industries and manufacturing of the future is really what I'm seeing today, is that people are no longer looking at where am I today, they're looking at where am I going to be in 3 years, where am I going to be in 5 years. And I think that thought process is developing a trend of the connected world and the connected product inside of industrial control systems.
Okay, well, I think that's all the time we have. Unless anybody else has anything they want to add, now's your last chance.
Thank you so much for having us.
Thank you.
Thank you very much.
I'd like to thank all of our speakers for their time today and all of the excellent insight that they shared about moving industrial control systems forward into the digitalized era. And of course, our sponsor, Schneider Electric Canada, for their support in putting together today's roundtable. Thanks again for your participation today, and have a good rest of your day.
Thank you, everyone. Thank you,
everyone.
Thanks.
Thanks.